Welcome to Lesson 2. In this lesson, you will learn about how we can create Spring Boot projects and with minimal configuration get a web application up and running, understand the structure of a Spring Boot project, why it's so important, see how the Spring MVC framework is abstracted away from you with opinionated default settings so you can create something very fast. So the goal here is to provide a Spring Boot project quickly, not get bogged down in the details of the Spring Web Framework, provide features with minimal configuration. What you must understand here is it doesn't generate code. It will wire up the web application context that Spring's Dispatcher Servlet needs for you with default configurations behind the scenes. If you want to override those defaults, you can provide your own configurations quite easily. We can also simplify the means of dependency management by using Maven and Gradle to bring in all the dependencies needed for a Spring Boot and therefore a Spring MVC application with minimal configuration of perhaps a Maven POM. There is a website out there which you can go to, start.spring.io, where you can generate a Spring Boot project. You'll see something like you've got here. Dependency management is quite critical. You can search for dependencies on the website and bring in what we call Spring Boot starters. So for example, I'm bringing in the Spring Web Starter here, which will bring in once we deploy our Spring Boot application by going out to Maven Central, all the dependencies needed for a Spring MVC project. So we select the Spring Boot starters we want. We decide what project type we want, Maven or Gradle, whether it's Java, what version of Spring Boot. We click the button, Generate Project, that you'll see at the base of the website, and you'll get a zip file. When you unzip that file, perhaps in Eclipse, you will see the structure that you've got here, all generated for you. We need to go through this structure because it's the basis by which it's making its opinionated defaults for your configuration. If you look at the Maven POM that you have, you'll see the Spring Boot starters, such as we have the parent one to bring in Spring Boot starters dependencies, all the jars needed for Spring Boot. And because we were using web, we have another entry to bring in all the Spring MVC jars. If you look at your class path, you will see a profusion of jars that have been brought in as courtesy of these Spring Boot starter entries in your POM, rather than listing them all in the POM, where the POM would end up being enormous. In our generated project, we will also see an application class. Here it is. Note the Spring Boot application annotation. If we look at that annotation in its source code, we will see that it is annotated with configuration, enable auto configuration, and component scan. So let's talk about enable auto configuration. That is saying I want all the opinionated defaults. Hey Spring Boot, create me a Spring MVC application. That's all you have to do. Everything else is taken care of in creating the Dispatcher Servlet and its web application context. The second annotation is a component scan I want to talk about. That is saying, well, the Dispatcher Servlet, the front controller, is going to delegate to subcontrollers or controllers, or REST controllers as we call them. Where are they? Well, they're going to be in the same package as this application class or sub-packages thereof. And then the last annotation configuration is saying that this class, this application class, can act as a Java configuration class where you can define bean definitions. By launching this class, this runnable class, you are going to launch your Spring Boot application. The structure then. So from the top, we have our application class. You can rename it. We then have source main resources. Underneath that, you will have a static subdirectory. It is here that the default configurations will look for style sheets, JavaScript files, images. If you have the Thymeleaf HTML5 dependency brought in by your POM because you stipulated that starter, your view resolver that the dispatcher servlet has to say which view do I go to is going to look in the template subdirectory for HTML files. So if my dispatcher servlet delegated down to a controller and that controller returned home, it's saying you want to go to the source main resources templates home.html page. Take me there, dispatcher servlet, because you have a dispatcher. You will also have configuration files. They will also go under the source main resources directory or a subdirectory called config. You will also have a basic skeletal test class generated in your source test Java directory. You also have your Maven POM with your starters, and you will also see the Maven dependencies directory. If you open that up, you will see all the jars that were brought in by the Maven POM when this project was built through a Maven build. You also have an embedded Tomcat server. By default, the embedded server will listen on port 8080. Under the hood, Spring Boot has created a new type of web application context, an embedded web application context, which is basically looking for a factory class that will create an instance of Tomcat for you, which will be completely auto-configured. Although we can deploy Spring Boot applications as WARs, more often than not, when you run the application class, you're effectively creating an executable jar which is being passed to Tomcat, and it will execute it on this embedded server. This makes Spring Boot extremely attractive for virtualization, such as Docker with Kubernetes, where the Docker images contain everything, the executable jar with its embedded server. So there's no deployment to a server here for us. It's done automatically when we run the application class. Okay, we're going to break now and have a lab. We follow the lab instructions. It'll tell you a little bit about setting up your Eclipse for Maven, and it'll have some brief lab instructions. It will tell you where the starter project is. We're going to use a starter project rather than generating one from Spring.io. You're going to make some changes there. So follow those instructions. You'll deploy it to an embedded Tomcat server. I'll walk you through the lab once you've completed it. So I'll see you on the other side. Hello. Here we are in the lab. A couple of things to point out: student work directory and the settings directory here, which is in your lab setup document. And we also have a Firefox web browser as well, which hopefully is going to render something like this in due course. So here's my Eclipse. The first thing I did is just to check my Maven settings. I came in here, I might type Maven user settings. Now I want to know it was pointing to there. If it wasn't, click on settings, click the file, bring it in, apply and close. Second thing I did is open the project from the file system. So I would come into student work, setup, pick the starter project, bring it in, hit finish. We're all good to go. There it is. At this point, you might notice a ton of stuff working down in the bottom right of your Eclipse. I think we just got a little bit there. It's building the project, basically. All good stuff. Now, I can't type quick enough, so I'm going to look at the solution now. So I'm opening up the solution, which you can always do. We can take a look at the structure. Source main resources, I've got an application properties file, a POM with the starter dependencies. When you built the project, it dragged all these dependencies in. Gosh, that makes it so easy. You don't have to worry about bringing in individual jars. It's great. Then we have a service. Here it is. Delegating down to a DAO. We'll be dealing with these things later on in later labs, but it's a map of students. We don't deal with a database. That's in another course. We have a student class. There he is. Default constructor, overload constructor, getters and setters. We have all that there. We have a student controller, which we'll deal with in another lab. That's going to come later. And then we have the application class. So the first thing to look at in the application class are these annotations that we ask you to put in. Let's select this first one, shall we, an open declaration. So this is the Spring Boot application annotation. The key things here, there is a component scan, scanning for this package and sub packages for Spring Managed Beans. There's an enable auto configuration, which basically creates the web application context for the dispatcher servlet with all the opinionated defaults. And there is also a Spring Boot configuration, which means that this class is also a Java config Spring configuration class as well. And we have others here where it can be placed, whether it's there in the bytecode or not, whether it's documented, whether it's inherited, if you have subclasses. We don't need to worry about those. So we ask you to put that in. We ask you also to put in a request mapping to /, which means all requests come to this student application class, which is now going to be, courtesy of our third annotation, a REST controller. Yes, it can be all things. It can be a configuration class, it can be a REST controller, it can be everything if you like. We could actually build a whole application around this one class. And then we ask you to put a get mapping here, and we're just going to return a string. So this is a REST controller tied to every request to this application that is going to delegate all requests to the home method to return the string hello world. Now, if we run this, so I right click on the application class, I'll scroll down a bit here, run as Java application. This is not a war. We don't need a server. There's an embedded Tomcat server because this is a Spring Boot project. We hit this and we should see a lot of activity happening in our console. There's the Spring banner. It's found the student controller, student application class, sorry. Let's take a look at the logs here. The important thing for me, Tomcat is initialized with port 8080. Tomcat started on port 8080. There is no context root. So why don't we come down here to Firefox. Let's see if we can open this guy. And we are going to type in localhost 8080. Looks like I've been here before. And there is hello world. We've come through the dispatcher servlet. We've delegated down through the enable auto configuration courtesy of the Spring Boot application annotation down to scan for controllers and REST controllers in this com.student package or sub packages of thereof. And then we've looked for something tied to the root context here, /, and it is an HTTP GET, and we have returned hello world. That completes our first lab. We've got our project all set up for multiple labs coming up. Thank you. Welcome to lesson 3, defining REST controllers. Our objectives are to just briefly talk about REST or representational state transfer. Create a REST controller and interact with a Spring Boot configuration file, and return some simple data from a REST controller. So let's talk about REST first. It's a software architecture for distributed systems to talk to each other, such as on the web. Roy Fielding is the father of REST as defined in 2000. The REST style of architecture consists of clients talking to servers. Clients initiate a request, sends it to a server, and the server responds. Requests and responses are built around the transfer of representations of what they call resources. So a representation of a resource is, I'm going to send you some textual data, frequently in the form of JSON or XML, and you're going to respond with a representation of resource in JSON or XML. A resource is basically anything that you wish to address on a server, typically a document or a representation of that document. We don't send the actual document back, we send back a representation of that document back in textual form. Unlike SOAP, REST strictly uses HTTP. SOAP was using it as part of its overall architecture. Let's take a look at HTTP. It's very simple. You must remember that it's textual. It consists of information stored in headers and a body. We can see here a request being made to a particular HTML page, index.html, using an HTTP GET method. I'm getting a resource back, a representation of that resource. In fact, it's going to a host called abc.org. I'm using Mozilla as the client, and I'm saying here that this client will accept a representation of the resource in the following media types: text HTML, application XHTML or XML, and that we will favor text HTML over XHTML and XML. That's what those numbers mean at the end. Giving my locale, and it will accept zipped up representations of resources for efficiency. Here's my response. It's saying that it's passing back a status code of 200, which is okay. And since we favor text HTML, we are getting text HTML back. And we've got a line break, and then we have the actual body of the message coming back. So it looks as if HTTP has specific methods. These are HTTP methods that you might be familiar with. A GET means I'm getting a representation of a resource from a service. I would like to get all the students in the department. The students in the department may be Java objects on the server, but I need a representation of that, a JSON representation of that collection. Head is almost identical to GET, but basically you're just passing back a response in headers. There's going to be no body coming back. So we might interact with a service just to get headers back. Post means I'm pushing a representation of a resource to a service where that representation resource itself does not exist. So I'm pushing something new. Put is saying I'm pushing a representation to a server for a resource that does exist because I essentially want to update it. I think delete is self-explanatory, and a patch is much like a put, but it's partial modification to a resource on a service. we create HTTP requests that go through the dispatcher servlet that use the defaults of a Spring Boot application to say, aha, this URL wants to go to this controller. Spring MVC annotational based framework is based off REST requests. The Spring Boot application class annotated with @Spring Boot application will scan for controllers or REST controllers annotated with the REST controller or @controller annotation and say these are the places I want to dispatch requests to. It will map URLs of an HTTP request coming in to the request mapping of a controller and then map the method that HTTP was using to a particular method within that controller. So here I have a REST controller saying any request coming in at all into this web application will come to this controller. If the URL is not concatenated with anything else, it will go to the method string home and return hello. Otherwise, it will do URL concatenation to say, oh, you passed me in /abcd. I come to the home controller because everything goes there because it's just slash. And then I look for something that's an HTTP get map method. There it is, get abcd. And it's saying concatenate abcd onto the URL that I map to. So if you pass in /abcd, you will return world. Note the request mapping on the class and the get mapping on the methods. Each URL is mapped to an individual resource on a server. Our resources here are controller methods that are returning data. They must be unique for REST, those URLs that resources are tied to. If we start up our Spring Boot application, you will see the log as we've got here, and we will see the Tomcat server starting, and it will say, as you see down the bottom, Tomcat started on port 8080 with a context path of nothing. So that's a context root of a web application, like a qualifier, if you like. So if I type in localhost 8080, if you remember, 8080 means there's no concatenation of a URL beyond the default URL, so to speak. So that means I will be mapped to home controller and the method home. If I type in /abcd, I will be tied to the home controller and the method getABCD. And you will see that those controllers respond, passing back to the dispatcher servlet. And because it's a REST controller that I'm using, it writes what was returned from those controller methods to the response object in textual form. Here's just simple string, so I'm pretty safe in that my string in Java can be converted to a textual string. It's written to the response object, and that's what's returned to the browser. Hence you see the two responses you see here. So here we have a situation where we want to get hold of maybe some parameters passed in from the request. You see a query string. So let's take a look at the URL. I'm mapping to a controller called myHeader. It's then being concatenated on param. Do I have a method mapped to myHeader param? Yes, I do. It's called getParameter. The request argument is okay. Spring Boot saying, I know what that is. Don't worry about it. I'll inject in a handle to the request object. We can get the parameter employee and get Mary and return hello Mary. We have other ways to do this that are far more convenient. We'll see those later on in the course. Now we have this configuration file under source main resources called application properties. We want to use it to customize the default configurations. We won't do much here initially, but what we'll do, we'll put in a couple entries called greeting and salutation. Note the expression language, that's a placeholder and it's resolving in the properties file. Hey, there should be a property called greeting. Could you inject it into this placeholder for salutation? So salutation will actually be hello world. We're actually going against the Spring Environment object. This properties file is being parsed and read into the Spring Environment object, which is like a glorified map. And we're actually going to the Spring Environment object and say, is there a property called salutation? Is there a property called greeting? So what will happen now when we access this controller request mapping employee that you see here, and I pass in 8080 employee, it's going to go to this controller and look for a get mapping. There it is, get str, and it's going to return str. The at value annotation is using el to say go to the Spring Environment object, find me a property called salutation, injected it into the employee controller so we can return it, and it should return hello world. So let's talk about dependency injection in Spring. Injecting in a dependency, wiring up an object graph. You probably saw that in our Spring Core module where we wired up object graphs of simple beans. This is where we transgress from the web application context to the root context in a Spring Boot project. The root context is non-web stuff. The web application context is everything the dispatcher needs, such as controllers and REST controllers. So we're really transgressing from controllers to model parts of our application. The way we do this is we simply inject in a bean from the root context, such as employee DAO. We could use autowired, we could use inject. We're now moving from one context to the other, so to speak. We're moving from controller to model. And what happens here is that when this REST controller get mapping mapped method is executed, get all, it delegates down to the model, the DAO, and executes the method get all. This will return a collection of, I guess, employee objects. Now I can't send employee objects back through HTTP. I have to convert them through the web application's context helpers into text. That text, because we've put a produces media type application JSON, which is actually the default based off the class path of the POM, it will convert that collection into a JSON array. So here you see the response in the browser. The browser is saying, I got JSON back. Okay, we're going to break here and do a lab. You're going to build upon your existing project to access some simple data that we could return back with a request to a REST controller. Follow the lab instructions, make sure your Maven is set up, and I'll see you on the other side. Welcome to lesson number 4, using properties. Here we will look at the Spring Environment object, see how we can customize our application. This environment object can be configured using the application properties file, but also another file, application YAML, which uses a different form of notation. We will also show you how to set the values of predefined properties in either of these files, application properties or application YAML, in order to customize our application. And then we'll look at Java configuration classes, where we can populate these classes and inject them into controllers in order to get hold of configuration data that we can use. We've seen the application properties file. It's under the resources directory. More often than not, it is in a config subdirectory of source main resources. We provide configurations in this file for our project, as we've seen through key value pairs. However, we can set other properties that Spring Boot recognizes, not ones that we've made up. An example of this is server.port, server.servlet.context-path. Yes, that's right. We're changing the port for our embedded Tomcat server, and we're changing our application to have what we call a context root. So it's like a prefix that gets put in front of all our mappings for our controllers. They do not appear in the REST controllers. It's done for you through this configuration. So before, when we had localhost 8080/employee, to get hold of that REST controller now, it would have to be 8081, the context root work, and then employee. To prove that the values in the application properties file are actually going through the Spring environment object that represents a handle on the configuration for our running application, we can actually write this little bit of code I've got here, where I've actually injected in the Spring environment object, and I'm getting the property salutation. I'm getting a system property such as the Java runtime version. It's pretty unusual to do this. We have the @value annotation that we saw previously, that we can inject in these properties using EL, and that would be the preferred way to do it. Now, YAML files, an alternative to application properties. It's a superset of JSON, and it makes clear the representations with respect to parent-child relationships between our properties. Spring will automatically support such files as an alternative approach to properties. On the left, you see our application properties with the properties that we have so far talked about, ones that we provided and ones where we overrode the defaults in Spring Boot. On the right, we see the application YAML equivalent. And we've added some more. You see the key value pairs are now in a hierarchical format. We don't have duplication of server or something like that. This makes it very clear. You must be careful in the indentation. It is 2 spaces indentation, and it is space between the colon and the value. EL is represented in both, and you can access one from the other to some degree. What actually happens here, the salutation is actually accessing the salutation property in the properties file. What happens if I have the same property in application properties and application YAML? Well, the answer is properties is king. It will override what you have in your YAML file. So what we're going to do now, we're going to do a small lab. Go to your lab instructions, make sure your Maven's set up, and then I'll walk you through the lab once you've done that. So I'll see you on the other side. Welcome to lesson 5, request parameters, getting at parameter data. Here we will extract data from the HTTP requests coming into our REST controllers. We will return textual representations of server resources to our clients. Our resources are Java objects. They need to be transformed into text. For us, that will be JSON. And we will also have the ability to customize the response with respect to headers by responding with a response entity where we can add our own custom headers. So far, we have seen something like this with respect to extracting data from the request that's coming into a controller. I have a REST controller here with a single method get parameter. The request object's being injected in, and we're writing the Java code to get out the parameter employee. It's very long-winded, doesn't seem like a Spring way of doing it. The first way we can have Spring do the heavy lifting for us is to use something called URI templates, where the data is embedded in the URL. You see the placeholder here, example.org/foo/user ID. That's a placeholder. It doesn't have to be at the end. It could be anywhere in the URL. And below you see I typed in the URL and I put bar. Bar is in the position of where that placeholder is. So it's considered that is accessible data that we could extract out of the URL. How would we do this? Well, we know that controllers, first of all, and REST controllers make use of dependency injection to delegate down to the root context. And that's what I have here in this employee controller with the employee DAO. The next thing, I have a request mapping of employee and a get mapping tied to, and then we have this placeholder. What we're saying here is that if you pass in a URL of employee slash something, that something is in the placeholder position of the URL. We can extract that using the app path variable annotation. We give it a name ID because we may have more than one placeholder in our URL. We want the one called ID. I only have one here. So we extract that, pass it through converters, in this case to a long, and then we use that long to delegate down to the root context in the DAO to return an employee object. That employee object is then going to go through converters, passed into a textual representation of that object, i.e. JSON. So if I put in this URL, work as the context root, employee, controller, REST controller, and then 3 placeholder, I should get JSON ROS coming back in JSON format. In fact, it's being put into a response entity object, which might include headers and a status. And what you're actually looking at here is the payload. We're quite okay to do that unless you want to customize the response entity. That means we create our own. So here, I'm returning a response entity .ok. That's saying it's a 200 HTTP status code. I'm setting a custom header in this response entity builder that it's called, that comes out of the OK method of greeting, value hello world. And then the body is the payload from delegating down to the injected DAO. When you look at your response in modern browsers, you have DevTools. You can see my URL there, showing the status 200, and you can also see the custom header, greeting hello world. And you see other headers that are generated by default, content type, it's application JSON coming back, and date. Now, perhaps different scenarios result in different status codes, and that is true. We have lots of different HTTP status codes. Here's an example where I receive the ID, I delegate down to my DAO, but I don't get an employee back because maybe the ID doesn't exist on the DAO or wherever the data is being sought for from that DAO. So instead of returning a response entity of OK, I can return a response entity.bad request. Since bad request doesn't have a body, you can see here what I mentioned before, response entity is a builder. You have to execute the build command in order to build the response entity, as I've done there. Why didn't I do that? when we did the response to NT-OK? Because I used the body method and it does it automatically behind the scenes for you. The second means by which we can extract data is using a different annotation, request param. We can see here that I have a method no longer with a URI placeholder. It's just a straightforward path. Path is the default variable, so you don't always have to put it in. You might have seen me not put it in before. If it's the only attribute, it's considered the default. And you can see my request param. I'm looking for something called name.id. Where did that come from? Well, we can see the URL employee single question mark ID equals 4. That's where it's coming from. And it will extract it out of the query string and place it into the long ID here. But with request params, they don't always have to be present. So here you see in the first code snippet a default value if you don't find that request parameter. And secondly, you're saying, well, we'll accept it if you don't find it. It's not always required. This is an old way of doing it. The more modern, if that's the right word, approach to do it is actually in the code snippet below, where we create a Java optional. And then with the optional, you would do a get, which would fall over if it wasn't there. More likely you would do an or else, and you could provide a default value there. So this endpoint, as we can now call it, this method in this REST controller can actually satisfy two URLs. When do you use a request param rather than a path variable? When it's optional. We talked about headers. We created custom ones when we did a response. What about sending headers to my service? How do I get hold of those? Well, three approaches here. The first approach is you injecting the entire request and get hold of the header by its identifier, user agent. Well, Spring likes to do stuff for us, so maybe we shouldn't really be doing that. It's very old-fashioned. So what about injecting in using @request header? Well, that's great. We can see we can get hold of it. It's a string. But what if we don't provide it? It's going to say I don't have that header. I'm going to be in trouble. So I'm looking at my last example here to say that the request header is optional. What about combining both approaches, path variables and request parameters? Here's an example where I'm returning a collection. It will return a JSON array of employee objects. Path variables are mandatory. They're part of the URL. I have to have them. Request parameters are optional. So you can see I have provided a path on my get mapping, which contains a placeholder for the path variable, mandatory. And then I put in an optional request parameter. And I'm using that optional request parameter to filter an existing collection coming back from an injected DAO. If it contains something optional, I will use it. Otherwise, I just say, does the last name contain something, anything really, an empty string. This means that again, we have a single endpoint that can satisfy two URLs. Work employee search Eric with a request param and without a request param. Okay, we have a couple of labs for you to do. One will follow on from the other, both using path variables and request parameters. Once you've completed the labs, I'll walk you through both of them. So I'll see you on the other side. So here we are in our lab, and we started our lab off in Student Controller. So I'll open that class up. And it wanted us to add a couple new methods. So you can see them here. Student request mapping at the class, at the get mappings, a placeholder for ID, path variable, and then /single for the other one using a request param that can be optional. This will delegate down to our student service, passing in the path variable here of the ID of the student we want, and then down here we'll be passing in the request param to get a single student again by its ID, but this time we're using a different type of annotation, which is optional. So we're setting a default of 1L, as you see there, inside the get single student method. We also, while we were in this class, wanted to change the get message method, which was delegating down to our student properties to get a greeting. What we're going to do here, we put in a request header, user agent. Doesn't look like it's optional. And what we're trying to show here is that we can extract headers quite easily from the request. So we're just going to concatenate it on the end of the string that's returned from this method to confirm, yes, we did capture that particular header. At this point, we said go ahead and launch your application. Hopefully my console will kick in with some activity. And we want to test out these endpoints. One to get the header, one to get a single student back using a path variable, and one to get a single student back by using a request parameter. So I'll start up Firefox. Looks as if our application has started. 8081, Context Root College. So I'll come into here, local host 8081. College, student, message. We'll do that one first. Yep, it looks like we extracted the header. We're using Mozilla here as the user agent. So that one worked. The second URL we wanted to do was using a path variable to get a single student. Let's see if that works. Yes, we've got Eric Colbert. If you don't believe me, we can always change this to number 2 and we can get Mary Contrary. And then the third one, I can type it, single request parameter ID equals 1. We're using a request parameter now. We can change this to be 3. What will happen if we don't use this request parameter? Our default kicks in, our optional. So we're now receiving each of our endpoints, receiving their data, header, path variable, request param. So that completes lab 5.1. So welcome to lesson 6, posting data and content negotiation. Here we will create REST controller endpoint where we can push data to it through an HTTP post. We'll also create Java clients to interact with our services. We'll be using something called REST template. We will then explore the principle of content negotiation, where your services can make decisions on how the textual representation of resources, i.e. Java objects, are to be returned, JSON or XML. And then we'll also look at a different type of client, very briefly, an AngularJS client that can be used to trigger your service endpoints and consume them in JavaScript. So far we have been using gets. It's time to do a post. If you look at the code snippet here, I have a post mapping saying that the method is tied to an HTTP post, and you'll see that I have a request body annotation for the argument. What's going to happen here, the textual payload of a request is going to be marshaled into an employee object, and that employee object will be injected into this method. Once it's injected in, it looks as if we're delegating down to a DAO to add the employee and generating a receipt object, which will be sent back as a response and rendered into text. The default's JSON, so I would guess it would be JSON. Now, we can dictate to a degree on what our service is tied to with respect to the type of data being posted to it. A service is unique by URL and the HTTP method name, but also we have these attributes produces and consumes, which can guarantee uniqueness of an endpoint. In this code snippet, I have both. The produces is what you think it is. What am I sending back? In this example, we are sending back either JSON or XML, but because JSON comes first in the list, we will favor JSON. As we'll see, the accept header on a request is being used to dictate which of these media types will be used with respect to rendering a response. If we don't send an accept header, it will take JSON because that's the first one. The consumes is to do with posting. It's for saying we favor JSON, but we'll also satisfy XML payloads being sent to us. That actually looks at the content type header that's being passed into the server on the initial request. We could have different methods for different media types. Here you can see we can list an array of the media types that we will accept. What if we send something that's not in our list? You'll get an exception, unacceptable media type. So here then we have a post. In this case, we will only accept JSON in and JSON out. If we send XML, we'll be out of luck. We'll get that exception. Let's say we're successful and the JSON is marshaled into an employee object. The question is, what do we return? When we post data, if we look at the REST specification by Roy Fielding, posts do not return data. We push data to the service. We will return, as we've got here, a response entity of accepted unless we throw an exception. In this situation, when I add the employee will be given an ID to say it's been successfully perhaps inserted on a database. If we don't get that ID, we're going to return a bad request by building a response. But if we do, we shouldn't return data. So how do we know this insert was good? Well, we return the accepted, but we also return a location header with a URL that identifies the URL you would have to go to in order to retrieve the data that was posted to the server resource. In this case, it looks as if it's just /ID. So the snippet below is showing you, hey, if you make a GET request to the URL that's returned in the location header, this is the service that you would go to with the ID that you got back in that URL to get the inserted employee. Okay, so we've got a little lab for you now to post data. In this lab, you will just create the endpoint. We won't test it yet. And I'll walk you through the lab once you've completed it. So I'll see you on the other side. So now we've created some services, both retrieving data with HTTP GETs and posting data to push data to our service. We want to test these out with Java clients to simulate maybe one service calling another or your web application calling your services. But making remote calls are complicated. So Spring provides us a REST template class with an extensive API to abstract away the complexities of the remote call. The API is really based around HTTP methods. So for example, we have methods such as GET for object, GET for entity. The GET for object is basically going to extract the payload out of the response. The GET for entity is going to return you the entire response entity. And we also have POST for entity for doing a POST request. Any objects that are sent through a POST on the REST template or retrieved through a GET on the REST template will go through the same converters that our services have. So we could send an object converted into JSON and we get a response of JSON converted into an object. They always go against a running service. Let's take a look at the API. Here's the GET for object. The parameters for this method are the URL, what you want to do with the payload when it comes back, i.e. marshal it into what, to class, variable arguments of values for placeholders if your URL has placeholders in it, which would be used, for example, for path variables. So here I have my new REST template, get for object to this URL. You want the response converted into a Java string, and you have a placeholder. So positionally, it's going to align itself. So 1 will be put into the first placeholder. It just happens to be 1. This is the service it's going against. The path variable is used, delegates to the DAO. If we don't get 1, we'll send back a bad request. If we do get 1, we'll send back a 200. And in the body, we will send back an employee in this response entity. The REST template receives that response entity. By this time, the employee object has already been converted on the server side into JSON. So it'll take the JSON and convert it into a Java string. And that's what you see here. The GET for entity Once again, a get. The response is basically converted into a response entity at the REST template end. This means we have the ability to get hold of the status code and maybe header information. The parameters for the method are the URL, what you want to do with any payload in the response entity in terms of marshalling it into what, and once again for URI templates, varargs. So here's my URL. We're going against a template, we're getting for an entity against that URL. The payload is to be parsed back into a Java string, and we have one URL placeholder, which we're going to put 1 in. This returns a response entity. We said that we wanted to create the response entity from the response at the template end as a response entity with a string payload. So note the generic. We can now get hold of the status code and we can get hold of the body. We're going against the same service as before. We can see the result there, getting the status code. The third method we could do is exchange. It doesn't have a get in front of it. You have to stipulate what HTTP method you're using. It does return a response entity. The parameters are the URL. You have to stipulate the HTTP method. An entity, be it headers and body or just headers that we wish to write to the request. So this would be like if we were posting something. It can be null if you're not sending anything. What you want to do with the response when it comes back with respect to its payload. And if you have a URI template, you have the placeholders in the URL. So there'd be varargs of the values you want to put into the placeholders. So here's my code. Note, I'm creating some headers. I'm creating an accept header of JSON to say I would like JSON back from the service I'm about to call. So we're creating these headers and we're creating an entity that just contains headers. We then use the REST template exchange method to the URL. We're doing a get. We're passing in an HTTP entity, which is just headers. The response payload will be converted into a string. And we have varargs, we just have one because the URL is templated. With this approach, we can get the status code, we can get the body, and we can get the headers, and you can see them there. Looks like we did get JSON back because that's what we asked for with our accept header. If you didn't want to send an entity with any headers in, you could just put null in the third argument of the exchange method. Our next example is a little bit different. We're doing an exchange to a URL. We're not sending an entity. We do have a templated URL with a query parameter there, so we're using varargs, but look, we've got an employee class, not string class, and our response entity is of a generic type of employee. We're marshalling the response that's coming back, which is JSON, because we saw the content type was JSON before, and we're marshalling it directly, not into a Java string this time, but directly into a Java object, an employee object. Here's a JUnit test. We're just doing a negative test to show you going against the same service, same URL with a request parameter, and we're asking for an employee. 99 is its ID. So we're going to pretend that 99 doesn't exist on the server side when we go against the DAO. So we should be getting a bad request back And that's what we're asserting. Now, when we return collections of data, more than one object, we have the opportunity, one, of just returning it into a string and parsing it with the Java API for JSON parsing. But again, that's not the Spring way. Let Spring do the work for you. So we have this parameters type reference, which has a generic dictating of what the parameters type reference will be. You'll notice it's empty because I'm creating an instance of an interface. It has a series of default methods in it. I'm just using this to give it the generic of what I want. The generic is a collection of employees. I'm using Exchange, you have to with this, the URL, a get, I'm not passing in an entity, and my parameters type reference is deciding what to do with the response payload when it comes back. By taking this approach, it will take the JSON, build a collection of employees from the JSON, and populate employee objects to insert into that new collection. So I'm asserting the status code was okay, and I'm iterating over the body of the response entity, which is now a collection of employees. That's the service I'm going to. I can see the toString method being executed in my system out print line. I've successfully got those objects out. Posting data. I've created a new employee. No longer using get for entity, I'm using post for entity. I've got my URL and I've got my new entity. My entity is my employee object. I'm wrapping it. I'm posting it. You're going to get a response back. What do you want to do with that response? Whatever comes back, I'm saying to use the default type approach, which is to say it's going to be of a string. I'm then saying, response entity, you have some headers. Get me the location header. Get me the first location headers. HTTP headers do not have to be unique. Potentially, I could pass back lots of location headers, but that would be kind of crazy, but it's possible. And look what I'm doing now. I'm doing a get for entity with the URL that I got back from the posting to go back and actually get the employee that I inserted and marshal it directly into an employee class. This is the service I'm going against. You're seeing exactly how we would interact with the service to push new data to it and to verify that that data was indeed received and processed by using the location header. We can do this with Exchange. Same scenario, using the Exchange method, using the HTTP post, passing in an entity, wrapping my employee, executing it, getting the headers, the location header out, going back to the service, using the URL from the location header to get the inserted employee. Just another approach to doing it. Okay, so we are going to break for a lab. You have your lab instructions for the lab. Make sure your Maven's set up too. Always check that. Follow the instructions. I'll walk you through the lab once you've completed it. We're going to interact with our services by using REST template. I'll see you on the other side.